Okay, so hopefully your Unit 3 test went good. You did good on it. Today we're going to start the first of 2 units that deal with nothing but triangles. So for probably about the next month, that's all we'll be looking at. Triangles, 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 triangles. You'll be tired of triangles after the next month. But we gotta start somewhere. So today we're going to start by classifying triangles by their angle measures, by their side lengths, and then we'll get into different smaller theorems and stuff. It may be a long day, but just buckle up, hold on for the ride. So, a triangle, let me get a good pen color here. A triangle, which we denote with the little triangle shape, is a polygon with 3 sides. They can be classified by their sides or by their angles. So we're given this triangle right here. The sides of this triangle are segment AB, BC, and then CA. The vertices, which is a fancy way of saying the angles, are angle A, angle B, and angle C. So we got our sides, we've got our angles. Now they want us to classify, that's what we're doing here, we're classifying the triangles based on information they give us about the angles. So for this first one, it's an acute triangle. Simply because it has 3 acute angles. The next one, all the angles are the same. So we call it an equiangular, it's a weird word, equiangular triangle. Meaning that it has 3 60-degree angles. Now, since these are all 60 degrees, what kind of angle is a 60-degree angle? They're acute angles. So that means this is also an acute triangle. It's just a special type of acute triangle. The next one, we have a right angle, and it's called a right triangle because of it. That one right angle names it. So it has one right angle. And then the last one, this angle right here is obtuse. So we call this one an obtuse triangle because it has one obtuse angle. Okay, so let's get some practice classifying these. So the first one they ask us to classify is triangle EHG. So that triangle. Notice here I have this box in the corner. That tells me I have a right angle. So this one has to be a right triangle. Okay. So we got the next one. The next one they ask us to look at is EFH. EFH. It's going to be that one. Now, this angle right here is 60. What does a whole line have to equal? 180. I'm going to have to right here do 180 minus 60 right quick to get 120 degrees, because that's what that angle is. So what kind of triangle is that one? It's obtuse. We have an obtuse angle. Okay, next one. Erase my picture. FHG. So FHG. So it's going to be this one. They tell me that this small piece of angle H is 30, but this tells me it's 90. That whole angle is 90. So I need to do 90 minus 30 to get 60, which means this top angle up here is 60 degrees. So they're all 60, which means it is equiangular. But what did I say every equiangular triangle also was? Acute. So this is equiangular and acute. Okay, now let's classify them based on side lengths. So for the first one, we're not told anything about the sides, not that any of them are equal. We call this a scalene triangle because it has no congruent sides. Now, if there's at least two sides that are congruent, so this one, we're going to say at least two sides. At least two congruent sides, which that's marked by these little bars right here. This is an isosceles triangle. And then the last one, all three sides congruent. So we have all sides are congruent. This is an equilateral triangle. Now, an equilateral also has at least two sides congruent, so it's also isosceles. So it's both. It's equilateral and isosceles. Okay, so let's classify these next ones based on their side lengths. Unless they tell us, do not assume angles or do not assume segments are congruent. They may look like it, but unless they tell us they're congruent, do not assume. Okay, A asks us about triangle A, B, C. So that triangle. They tell us all the sides are congruent. That's what these red marks mean. So this is an equilateral. All are the same. And all equilaterals are also isosceles. Okay, next one, they ask about triangle ABD. ABD. Now, notice down here that this whole side would have to give us 15 plus 5, which is 20. So we got 20, 15, and 18. Those are our sides. None of them are the same, so we say it is scalene. And then, now we're at part C. They ask us about triangle EHF. These two marks tell us that two of them are the same. Which one has at least two the same? Isosceles. These two marks tell us that's an isosceles triangle. Okay, now we have to use some properties to show or to find different things. So they ask us to find the value of LK. So what is this distance here? We've got to find it. That's what we want to find, x plus 3.2. Now, don't just tell me that's the answer. Find it. What do we know that can help us? We know these two sides have to be congruent to each other. So I can say 4x minus 1.3 equals x plus 3.2. I don't, unfortunately, have the room to try to squeeze all my work on, but know that I'm going to move my x over. So that's going to make it 3x minus 1.3 equals 3.2. I'm going to add 1.3. I'm going to get 3x equals 4.5. Divide by 3, and I get x equals 1.5. Now, they don't just ask me to find x, they ask me to find LK. So that means I have to Plug it in, plug it in. So LK equals 1.5 plus 3.2. It's going to give us 4.7. That's what LK equals. 4.7. Now B asks us to find the y on equilateral triangle FGH. Notice that all of these are equal. They're all equal. If I just need to get y, it doesn't matter what two I pick as long as I don't pick the same one. I just need to pick two of them. So I'm going to pick the 3y minus 4 and set it equal to the 2y plus 3 because these sides are equal. So to get y, I just set them equal. So I'll subtract my 2y over and get y minus 4 equals 3. Add 4 and I get y equals 7. That's what it asked us to do. It just said find y. So we found it. Okay, so that's the front of the notes. Now let's flip over to the back. So on the back, we have the triangle sum theorem. Essentially, all it says is that if you add up all the angles, you'll get 180. So, angle A plus angle B plus angle C, all equal to 180. Okay, so they want us to use this fact to find different angles in our picture. The first one they ask us to find is angle NKM. NKM is this angle right here. That's what we're trying to find here. Well, we know that all three of these angles in this small triangle up here, all three of those angles have to give you 180. So, I'm going to add up 48 and 88. I'm going to do that up here. So 48 plus 88. That'll give me, let's see, 16, 136. And then I'm going to subtract 136 from 180, which will give me 44. So that means this angle is 44 degrees. Now, the other one they asked me to find is angle JLK. So JLK, that's this angle. So what I actually need to do, since I only know one of my angles, I need to find this angle first. And then try to find my other. So I'm going to have to add, since I know a whole line gives me 180, I'm going to have to add 104 and 44 to get 148, and then subtract 148 from 180 to get 32. So this small angle right here is 32 degrees. So now I'm going to have to add 70 and 32. It's going to give me 102. And subtract that from 180. 180 minus 132 is... Wait, not 132. Where on earth did I get 132? 102. 180 minus 102 is 78. So this angle right here is 78 degrees. So this problem took us a little bit, but that's okay. We got it done. Now we have several corollaries, theorems, all that good stuff to look at. So if we're talking about a right triangle, the acute angles in a right triangle are complementary, meaning that angle D plus angle E give us 90 degrees. Because we already have one 90-degree angle right there. The measure of each angle of an equiangular triangle is 60 degrees. So angle A is equal to angle B, which is equal to angle C, and they're all equal to 60. So that's a couple of corollaries dealing with angle measures. Now we have the exterior angle theorem. It's based on the fact that a remote interior angle is an interior angle that is not adjacent to a certain specified exterior angle. Think of remote like this. You're remote learning, meaning you're not at school. You're remote learning. So a remote interior angle is the angles that are in the triangle, but they're not next to my outside angle. So remember, interior means inside. Exterior means outside. So if 4 is our desired angle, so 4 is an exterior angle, we want to find the two angles that are not close to 4. They're remote. They're away from it. Angles 1 and 2 are considered remote interior. They're away from that outside angle. What's special about this relationship, though, is that angle 4 is equal to angle 1 plus angle 2. So let's actually go work an example with that. We'll come back to this other theorem. While that's fresh on our mind, let's work an example with it. So they ask us to find the measure of angle J. They want us to find this value right here. Okay, well, by our exterior angle theorem, we know that these two are remote from our exterior angle. So if you add those two together, you'll get your exterior. So that's what we're going to do. We're going to say 6x minus 1 plus 5x plus 17 equals 126. Then I need to combine like terms. 6x plus 5x is 11x. Negative 1 plus 17 plus 16 equals 126. See if I can squeeze this in. I'm going to subtract 16. 11x equals 110. So x equals 10. However, it doesn't ask me to just find x. I have to find angle J. So I have to take this 10 and plug it in for x. So the measure of angle J equals 5 times 10 plus 17, which is 67 degrees. So there's our answer for that one. Okay, now let's go back up and catch this third angles theorem. What the third angles theorem says is that if two angles are congruent, then the third one has to be congruent too. So here they tell us that L is congruent to R. So angle L is congruent to angle R. And angle M is congruent to angle S. That means that we can conclude angle N must be congruent to angle T. If L is congruent to R and M is congruent to S, then N has to be congruent to T. So let's look at our picture here. They ask us to find the measure of angle C, which is this part right here. That's C. Well, we know that A is congruent to D. So A equals D. We also know that B equals E. So what's that mean C has to equal? C has to equal F. So let's set up an equation that says that y equals 3y minus 72. Subtract my y over, so minus 3y. It's going to be negative 2y equals negative 72. Divide by negative 2. And get y equals 36. Now, the measure of angle C is equal to just y degrees. So that means it's 36 degrees. I mean, we plugged it in, but C is just y. So it worked out to be that simple. Okay, so I told you the lesson was long. I'm sorry, but stay tuned for the guided practice.